All right, let's dive into something pretty vital, huh? Something you literally can't live without.
Hmm. What's that?
Your heart.
Ah, good one. And no, we're not talking Valentine's Day stuff here.
Nope, no cliches for us.
Based on these study notes someone sent, looks like somebody's prepping for like a cardiology exam or something.
Maybe it's you listening, right?
Could be. Either way, we're going to make this fun.
Yeah, fascinating and actually surprisingly useful.
You'll practically be heart experts by the time we're done, I swear.
I love it. Okay, first things first.
Yeah.
What does the cardiovascular system actually do?
It's about balance, keeping things in check.
Homeostasis, right?
Yeah, exactly. Think of it like your body's ultimate delivery service.
Okay, I like that.
It's constantly transporting things like oxygen, nutrients, all that good stuff.
Right, got to get that fuel to the muscles and everything.
And also, it's taking away the waste products, too.
Ah, so it's a two-way street.
Absolutely. And the heart,
Yeah.
with this network of blood vessels.
The veins and arteries and all that.
Yeah, exactly. It's like the engine that keeps everything running.
So it's way more than just a simple pump,
A
then.
little more.
It's like, I don't know, the grand central station of my body.
I like that analogy.
So tell me more about the heart itself, then.
Okay, picture this. Nestled a bit to the left of center in your chest,
Okay.
there's a space called the mediastinum.
Mediastinum, all right.
That's where your heart is.
Tucked away in there.
It's about the size of your fist. But don't let that fool ya.
Oh.
This muscle pumps around 5 to 6 liters of blood every minute.
Wait, hold on. 5 to 6 liters a minute. That much?
It's a lot, right? Enough to fill a bathtub every hour.
A bathtub every hour. Seriously.
Yeah, it's incredible.
I had no idea my heart was working that hard.
Well, it is.
So these notes mention something about, like, chambers in the heart. I always thought it was just kind of one big open space.
Oh, no. Much more sophisticated than that.
Okay, tell me more.
The heart actually has 4 distinct chambers.
4.
2 up top called the atria.
Atria, okay.
2 lower chambers called ventricles.
Ventricles, got. So what do they all do?
Okay, think of the atria as receiving rooms
Receiving rooms
for blood coming back to the heart after its trip around the body.
Okay.
And the ventricles, they're the powerful pumps.
Ah, so that's where the real action happens.
Exactly. Sending the blood back out.
Makes sense. So we've got blood coming in, blood going out, all separated.
Yep. Neatly organized.
But how does the heart make sure it all flows the right way?
That is a great question. That's where the valves come in.
The valves, okay.
These incredible structures act like one-way doors.
One-way doors, so there's no going back.
Exactly. That's how they make sure blood keeps flowing in the right direction.
That's brilliant.
Prevents any backflow, too.
Okay, that makes a lot of sense.
They're like a traffic system, but inside your heart.
That's a great way to put it. And speaking of layers, these notes mention something about the heart having a few of those too.
Oh, it does. It does.
You tell me about that.
Okay, think of it like an onion.
An onion.
But instead of making you cry, it's keeping you alive.
Okay, I like that.
The outermost layer is called the pericardium.
Pericardium. All right.
It's tough, kind of fibrous, and it's a sac.
So it's like a protective layer.
Yeah, like built-in bubble wrap, basically.
Protecting the heart from all the bumps and jolts.
Exactly. Shielding it.
Smart.
Yeah.
So what about the other layers then? What's under the pericardium?
Right, so beneath that you've got the epicardium,
Epicardium.
a thin outer layer, and then we get to the myocardium.
Bicardium.
That's the muscular middle layer.
Okay.
That's where all the action is.
The real muscle of the heart.
Yeah, it's made up of all these specialized muscle fibers.
And those fibers are what allow the heart to contract.
Exactly. To contract and pump blood, all without you even thinking about it.
Automatically, wow. It's like a personal trainer working on my heart 24/7.
I love that.
So what about the innermost layer then?
Ah, that's the endocardium.
Endocardium, okay.
It's a smooth lining on the inside of the heart.
So it's kind of like the lining of a blood vessel.
Yeah, and in fact, it's continuous with the blood vessels, which creates a seamless pathway for blood to flow through.
Ah, so no rough edges for the blood cells to snag on.
Exactly. A nice smooth ride.
Okay, I'm ready to follow the path of a red blood cell now.
Oh, good.
Like, let's trace its journey through the heart.
Perfect.
We need to talk blood flow.
Absolutely. Imagine we're at that tiny red blood cell starting in the right atrium.
Okay, the right atrium, we're there.
We just came back from delivering oxygen all throughout the body.
Yeah, like we just finished a marathon.
Exactly.
Yeah.
And we need to get replenished.
Fuel.
We enter the right atrium through large veins
Okay.
called the superior and inferior vena cava.
The vena cava. Oh, yeah.
This blood is deoxygenated, meaning it's dropped off all its oxygen.
So it's ready for a refresh?
Exactly, needs a new supply.
Where does it go from the right atrium then?
Okay, so from there, we flow through a valve. Remember those one-way doors?
Oh, right, right. No going back.
Exactly, into the right ventricle.
The right ventricle? Uh-huh.
And then the right ventricle pumps us out to the lungs
Out to the lungs. Okay.
via the pulmonary artery.
Wait, the pulmonary artery, don't arteries usually carry oxygenated blood?
They do, but the pulmonary artery is the exception.
It's the one that carries the deoxygenated blood.
Yep, the only one. We're headed to the lungs to pick up that fresh supply of oxygen.
Ah, so it's like a pit stop at the oxygen station.
I like that, pit stop.
And then what happens when we get to the lungs?
Okay, once we reach the lungs, it's like a spa day for our red blood cell.
Spa day.
Gets a fresh dose of oxygen, turns bright red again.
Refreshed and ready to go?
Exactly. And this oxygen-rich blood then travels back to the heart.
Back to the heart, okay.
Through the pulmonary vein.
Pulmonary vein?
And this time, it enters the left atrium.
Ah, so we're back at the heart, but on the other side now.
Exactly.
So what happens next?
From the left atrium, we flow through another valve.
One-way door.
You got it. Into the left ventricle.
The ventricle.
This is the strongest chamber of the heart.
Ah, I bet.
And for good reason, it has a big job.
What's that?
It pumps that freshly oxygenated blood
Yeah.
out to the entire body.
Wow, so it's the heart's heavy lifter.
You could say that.
And it does that through
The aorta,
the aorta, the biggest artery.
the largest one in the whole system.
Okay, so we've got this loop, blood flowing through, getting reoxygenated in the lungs, and then delivered back to the body.
Exactly, continuous loop.
But how does this pumping actually happen?
Ah, that is the cardiac cycle.
A cardiac cycle.
It's a dance, a coordinated dance of contraction and relaxation.
Okay.
We call the contraction phase systole,
Systole.
and the relaxation
Wow.
phase diastole.
Wait, systole? Diastole?
You recognize those words?
I think that's what we feel as our pulse,
You
right?
got it. Every lub-dub is one complete cardiac cycle.
Seriously. Wow.
And your heart is doing this cycle, on average, about 72 times a minute.
72 times a minute.
Over 100,000 times a day.
My heart never gets a break.
Nope, tireless worker.
Incredible. And speaking of that lub-dub sound,
Yeah,
what exactly causes that? It's like the soundtrack of our lives.
it is. And it all comes back to those valves.
The valves again. Wow.
The lub sound happens when the valves between the atria and ventricles close,
Ah.
as the ventricles begin to contract.
So it's not the muscle itself making the sound, it's the valves.
Yep, snapping shut.
So what if there's a problem with those valves?
That's when you might hear something extra.
Extra.
Additional sounds, called murmurs,
Murmurs. Interesting.
could indicate there's an issue with a valve.
Okay, so that's something to be aware of.
Definitely.
But tell me this.
Yeah.
How does the heart know when to contract and relax?
It's like it has a brain of its own.
It does, right? Is there like a control center in there?
There is. It's called the heart's electrical system.
An electrical system. Wow.
It's one of the most remarkable aspects of this whole organ, honestly.
So how does that work then?
It all starts with a tiny cluster of cells
Okay.
called the sinoatrial node,
Sinoatrial node.
or the SA node for short.
SA node. Okay.
It's the heart's pacemaker.
The heart has its own pacemaker. That's wild.
I know, it's incredible.
So how does this SA node do its thing?
It sends out electrical impulses
Okay.
that spread through the heart in a very specific pattern.
Like a carefully choreographed dance.
Exactly. And that's what causes the different chambers to contract in the right sequence.
So it's like an electrical current that's setting the heart's rhythm.
Perfectly put.
And we can actually see this electrical activity, right?
We can.
With those electrocardiograms, the ECGs.
Exactly. They're like a map.
A map of the heart's electrical journey.
I like that, showing the different phases of the heartbeat as those impulses travel.
That's incredible. Okay, I want to switch gears a bit now.
Okay, where to?
Let's talk about blood itself.
Ah, the other star of the show.
What can you tell me about the composition of blood? What's in this stuff that keeps us alive?
Blood is more than just a red liquid.
I'm starting to realize that, yeah.
It's a mix of plasma.
Plasma.
That's the liquid part.
Okay.
And formed elements.
Formed elements, what are those?
Those are the cells and cell fragments.
Okay.
We already talked about the red blood cells, the erythrocytes.
It's the tireless oxygen carriers, right?
Exactly. But there's also white blood cells.
White blood cells, I've heard of those.
Yeah. Also known as leukocytes.
Leukocytes, all right.
Those are vital for the immune system.
So they're like the body's defense force.
Exactly. Fighting off infections and keeping us healthy.
Wow, it's like a whole army in there.
It is. And then we've got platelets, too.
Platelets, those are the tiny ones, right?
Yep. Also called thrombocytes.
Thrombocytes, got it.
And they play a crucial role in blood clotting.
Okay, blood clotting. So that's how we stop bleeding.
That's it.
So it's like a whole team of specialists working together.
A well-oiled machine.
And then there's the whole blood type thing.
Ah, yes, blood types.
A, B, and O.
You got it.
Honestly, that always kind of confused me.
Yeah, it can be a bit tricky.
Can you break it down for me? Like, what determines those blood types?
Okay, so blood types are determined by the presence or absence of specific antigens.
Antigen.
Yeah, think of them like little flags or markers.
Flags on the blood cells.
Exactly. They identify the blood type.
Okay.
And the ABO system classifies blood into those 4 main types based on these antigens.
Based on those flags.
Yep. And each blood type also has specific antibodies in the plasma
Antibodies, right?
that react to foreign antigens.
So it's like a system to make sure everything is compatible.
Precisely. This compatibility is super important for blood transfusions.
Oh, right. So you don't want to mix the wrong types.
Exactly. Got to make sure the recipient's body doesn't reject the donated blood.
Wow, we've covered so much already.
We have. It's a lot to take in.
My head is spinning with all this information, and it's just part 1.
I know, right? But it's fascinating stuff. It really is.
Well, for now, I think we need to let this sink in for a bit. We'll be back soon with part 2 of our deep dive into the heart.
Looking forward to it.
Okay, we're back, and I'm still kind of amazed by all the stuff we talked about in part 1. The heart is way more complex than I ever thought.
Oh, for sure. And we're just getting started. Remember that electrical system we mentioned?
The heart's internal wiring.
Right. Time to really delve into that.
Okay, I'm ready. You talked about the SA node. That's like the heart's natural pacemaker.
Uh-huh.
It's hard to believe something so tiny is running the whole show.
I know, right? It's incredible.
So the SA node starts the impulse, but where does it go from there?
Well, it doesn't just stop there. The signal travels through the heart in a specific pattern.
Like a carefully planned route.
Exactly. It's kind of like a choreographed dance.
Okay, so there's a whole routine the electrical impulse follows.
Yeah, you could say that.
Tell me more about this routine.
So from the SA node, the impulse first goes to the atrioventricular node.
Atrioventricular node. Wow, that's a mouthful.
We usually just call it the AV node.
AV node, much easier.
And the AV node acts like a gatekeeper.
A gatekeeper, what do you mean?
It slows down the signal just a tiny bit.
Slows it down.
Yeah.
Why?
It's a strategic pause, you could say.
Okay.
This pause lets the atria, the upper chambers, fully contract.
Ah, so they can pump all the blood down to the ventricles.
Exactly.
Yeah.
Before the ventricles contract.
So it's all about timing,
It really is perfect coordination.
like a relay race.
Yeah, I like that.
So after the AV node, where does the signal go?
Okay, so then the signal keeps traveling down a pathway
Okay.
we call the bundle of His.
Bundle of His, sorry.
And then this bundle splits,
Splits.
into the left and right bundle branches.
So it's like a highway that divides.
Exactly. And these branches carry the impulse down to the bottom of the heart.
Okay, so it's spreading throughout the whole heart.
Yep, delivering the message.
And then what? What happens at the bottom of the heart?
From the bundle branches, the signal spreads out even more.
More spreading.
Yeah. Through a network of fibers called Purkinje fibers.
There are Purkinje fibers, are
And
there?
these fibers are what actually stimulate the muscles of the ventricles.
The ventricles, so that's what makes them contract.
Exactly. It causes them to contract and pump the blood out.
Out to the lungs and the body.
Yep, the whole system.
So that tiny electrical impulse from the SA node,
Yeah.
it basically sets off this chain reaction.
It does. It's amazing, right?
That powers the whole circulatory system.
Without us even having to think about it.
It just goes beat after a beat.
It's pretty remarkable. And remember those ECGs we talked about?
The electrocardiograms, yeah.
They're like a visual representation of this whole electrical journey.
Those squiggly lines on the screen.
Yeah. Each peak and valley shows a different phase of the heartbeat.
So can you walk me through how to, like, read those squiggles?
Of course. So the P wave, that first little bump, that shows the electrical activity spreading through the atria,
Atria, right?
causing them to contract. Then there's the QRS complex.
That's the big spike, right?
Exactly.
Yeah,
That one shows the activity in the ventricles.
making them contract.
Yep. And then lastly, you have the T wave.
The T wave.
That shows the ventricles recovering, getting ready for the next beat.
So much information in those squiggles.
It's like a secret code.
A code that tells us how the heart is doing.
Exactly. Doctors can use them to spot any problems with the heart's rhythm.
Okay, that makes sense. You know, something I've always wondered about is blood pressure.
Oh, yeah, blood pressure.
Everyone talks about it, but I'm not sure I really understand it.
It's basically the force of your blood pushing against your arteries.
Okay, the force of the blood.
It tells us how hard your heart is working to pump the blood.
So it's a measure of how much pressure is in the system.
Yeah,
And we
exactly.
measure it with two numbers, right? Like 120 over 80.
You got
What do those numbers actually mean?
Okay, so the top number, the systolic pressure,
Systolic? Uh-huh.
that's the pressure when your heart beats
When it contracts.
during systole.
Okay.
And the bottom number, the diastolic pressure,
Dice.
that's the pressure when your heart is relaxing.
Between beats?
Exactly, during diastole.
Okay, I think I'm getting it. But why are these numbers so important?
Well, healthy blood pressure is really important for overall health.
What happens if it's not healthy?
If it's too high, it puts a lot of strain on your heart and arteries.
And that can lead to...
Serious problems like heart attack, stroke, kidney disease.
Oh, wow, that's scary.
Yeah, high blood pressure is a silent threat.
So we need to keep it in check.
Absolutely.
How do we do that?
Well, lifestyle changes can make a big difference.
Like what?
Eating healthy, exercising regularly, managing stress.
So the usual healthy habits.
Pretty much. And sometimes medication might be necessary too.
To help lower blood pressure.
Exactly.
So taking care of ourselves is key.
It really is the best way to support heart health.
Okay, back to blood for a second.
Yeah.
We talked about red blood cells, but I know there are other types of cells in our blood too.
Oh yeah, there's a whole crew in there.
Can you tell me more about them?
You bet. So in addition to the red blood cells, we have white blood cells.
White blood cells.
They're also known as leukocytes.
Leukocytes, okay.
And these guys are like the warriors of your immune system.
So they fight off infections?
They do.
Yeah.
And there are actually different types of white blood cells, each with their own special job.
Like a specialized team.
Exactly. Like neutrophils are the first responders.
First responders.
Yeah, they rush to the site of an infection
Okay.
and gobble up the bacteria.
Like little Pac-Mans.
I like that. And then there are lymphocytes.
Lymphocytes, those are the ones I've heard of.
They're the ones that recognize specific pathogens.
Pathogens, those are the bad guys, right?
Yep, the bacteria and viruses that can make us sick.
And the lymphocytes produce antibodies to fight them off.
You got it.
So our bodies have all these amazing defenses.
We do. It's
Yeah.
a pretty complex system.
What about platelets? What do they do?
Platelets, also known as thrombocytes.
Thrombocytes.
They're like tiny little cell fragments,
Okay.
but they have a very important job.
Which is?
They stop bleeding.
Ah, that's right. Blood clotting.
When you get a cut, platelets rush to the scene,
Okay.
and they clump together to form a plug.
To seal the cut.
Exactly. And they also release substances that start the clotting process.
So they're like the body's repair crew.
Exactly. They patch up those leaks in the system.
Pretty important job.
Absolutely. But what if a clot forms where it's not supposed to?
Oh, that doesn't sound good.
It's not. If a clot forms inside a blood vessel,
Uh-oh.
it's called a thrombus.
Thrombus, okay.
And if it breaks loose and travels
Travels where?
through the bloodstream,
That sounds dangerous.
it is. It becomes an embolus.
An embolus.
And that can block blood flow to important organs.
Like the heart or the brain.
Yeah. And that can lead to serious problems like a heart attack or stroke.
So blood clots are good for healing cuts, but bad when they form inside.
Exactly.
Makes sense. What about blood plasma? What is that exactly?
Plasma is the liquid part of blood.
Okay.
But it's not just water. It's got lots of stuff in it.
Like what?
Proteins, electrolytes, hormones, waste products.
So it's like the blood's transportation system.
Exactly.
Yeah.
It carries all those things throughout
And
the
it
body.
keeps everything moving.
You got it. One of the key proteins is albumin.
Albumin, okay.
It helps to maintain the right balance of fluids.
To keep everything flowing smoothly.
And then there are globulins.
Globulins, what do they do?
They include antibodies, those fight infection,
Okay.
and they also transport hormones
Yeah.
and other important molecules.
So plasma is pretty vital.
It is. It keeps everything connected.
We talked about blood types earlier,
Right.
the ABO system, but I know there's another factor too.
Oh, yeah, the Rh factor.
What's that about?
It's another antigen that can be on red blood cells.
Like another flag?
Yeah. People with the Rh antigen are Rh positive,
Okay.
and those without it are Rh negative.
Rh negative.
This is especially important during pregnancy.
Oh, why is that?
If an Rh negative mom is carrying an Rh positive baby,
Yeah.
her body might make antibodies against the baby's blood.
So that could be dangerous for the baby.
It can cause complications.
So expectant parents need to know their Rh factor.
It's important information, for sure.
Okay, one last thing before we wrap up this part.
Yeah.
I've heard about the lymphatic system.
Ah, yes, the lymphatic system.
It's connected to the circulatory system, right?
It is. Think of it like the body's drainage system.
Drainage system.
It collects excess fluid from your tissues
Okay.
and returns it to the bloodstream.
So it keeps things from getting too backed up.
Exactly. But it's also really important for your immune system.
Oh, Oh, I didn't know that.
Yeah, it has lymph nodes.
Lymph nodes, those are the little bumps you can sometimes feel, right?
Exactly. They're like filters.
Filters for what?
They filter the lymph fluid and trap pathogens.
Pathogens, those are the bad guys again.
Yep. Bacteria, viruses, all that stuff.
Yeah. And the lymph nodes are full of immune cells.
Like lymphocytes, which attack those invaders.
So they're like security checkpoints.
That's a great way to put it. They keep the bad stuff from spreading.
That's pretty amazing. Why do they swell up when I'm sick?
That's a good question. When you're fighting an infection,
Yeah,
your lymph nodes are working overtime.
to fight the infection.
Exactly. So they get bigger and tender.
So it's actually a good sign, in a way,
It means your immune system is doing its job.
trying to keep you healthy.
Exactly.
Wow, the lymphatic system is way more important than I thought.
Oh, yeah, it's crucial. So we've covered a lot of ground here,
We have, from the heart itself to the blood and even the lymphatic system.
and we're not done yet. There's still more to talk about.
More. What else is there?
Well, in part 3, we'll talk about how exercise affects the heart.
Okay.
We'll also delve into coronary circulation.
Coronary circulation, what's that?
That's the heart's own blood supply.
Ah, interesting.
And we'll talk about some ways doctors can assess your heart health.
Okay, I'm looking forward to it.
It'll be a great way to wrap up our deep dive into the heart.
We're back for the final part of our deep dive into the heart. My notes mention something called cardiac output. What is that exactly?
It's a way to measure how much blood your heart pumps out in a minute.
Okay, that sounds important, but like, how do we measure it?
We take your heart rate, how many times it beats per minute, and multiply that by the stroke volume.
Stroke volume, what's that?
It's the amount of blood the left ventricle pumps out with each beat.
Ah, so it's kind of like measuring the heart's efficiency.
Exactly. It tells us how well your heart is delivering that oxygen-rich blood to the rest of your body.
So would a higher cardiac output always be better?
Not necessarily. It actually changes depending on what your body needs at the time.
Makes sense. Like, if I'm exercising, my heart's working harder.
Exactly. When you're exercising, your cardiac output increases because your muscles need more oxygen.
So my heart has to pump more blood to keep up.
That's it. And that's why regular exercise is so good for your heart.
Yeah, I've heard that.
It strengthens the heart muscle, making it more efficient at pumping blood.
So working out is like a workout for my heart, too.
You could say that. Over time, it can even lower your resting heart rate.
That's pretty cool. Speaking of working hard, I guess the heart itself needs a constant supply of oxygen, too, right?
Absolutely. It needs its own nourishment to keep going.
So how does the heart get its own oxygen?
That's where coronary circulation comes in.
Coronary circulation.
It's a network of blood vessels that specifically supply the heart muscle itself.
So like its own personal delivery service.
Exactly. The coronary arteries branch off from the aorta and wrap around the heart.
To deliver that oxygen-rich blood.
Precisely. But just like any other blood vessels, they can get blocked or narrowed.
And that can cause problems, right?
Definitely. That's actually how heart attacks happen.
Heart attacks.
Yeah, a heart attack occurs when blood flow to a part of the heart muscle is blocked.
Oh, wow. That's serious.
It is, and it's usually caused by a blood clot in a coronary artery.
Okay, so taking care of those coronary arteries is pretty important.
Couldn't agree more. A healthy lifestyle can really go a long way in preventing those kinds of problems.
So how do doctors actually check how well the cardiovascular system is working?
Well, one of the simplest ways is just listening to the heart with a stethoscope.
The old-fashioned way.
It might be simple, but it's still very effective.
What can they tell from listening?
They can hear the heart sounds, the lub-dubs, and detect any irregularities.
Like murmurs.
Exactly.
Yeah.
They can also check your pulse.
Ah, my pulse.
The pulse tells us the heart rate and rhythm.
So they can tell if it's beating too fast or too slow?
Exactly. And of course, they'll measure your blood pressure too.
Right, blood pressure.
And then there are more advanced techniques like echocardiography.
Echocardiography, what's that?
It uses sound waves to create images of the heart.
So they can actually see the heart working.
That's right. It shows us the heart's structure and how well it's functioning.
That's pretty amazing. And then there's the ECG too, right?
Yes, the electrocardiogram. It records the heart's electrical activity.
So many ways to check up on the heart.
It's important to have a full picture of what's going on.
I feel like I've learned so much about the heart in this deep dive.
Me too. It really is an incredible organ.
Absolutely. So for everyone listening, let's take care of our hearts.
It's the only one we've got.
Eat healthy, get some exercise, manage that stress.
And get regular checkups.
That's great advice. Thanks for joining us on this incredible journey through the cardiovascular system. I hope you learned a lot about this amazing organ that keeps us going.
Me too. It's been a pleasure exploring the heart with you.
Until next time, stay curious and keep learning.